All right, folks, as you see, I'm not here again today. The first thing I want you to know about this lesson is to ignore the do now because we're skipping a lesson because I kind of just want to do A9 before I do A8. Got a problem with it? Didn't think so. All right, so somebody in one of the first two cores asked me about when we're going to solve these trinomials. Well, guess what? Today's the day. Now, what's beautiful is if we just cover up this equals 0 here, we know how to do this. We factored this the other day because that's what we're going to do. We're going to factor to solve these. So without that 0 there, what we did is we made our little x. And remember, we would put this last number here, up here, positive 42. And we'd take the middle number and put it down here, positive 13. And we would ask ourselves what two numbers right here would multiply to make 42 and add to make 13. So we could go through all the different ways, but I can see right now 13, the most common way is 7 plus 6, and I know 7 times 6 makes 42. So positive, oops, my pen. So positive 7 times positive 6. 7 times 6 makes 42. 7 plus 6 makes 13. So when I factor this, it turns into x plus 7 x plus 6. And that's exactly what we did yesterday and the day before. We stopped right there. But now we have this equals 0. And that's the thing. Whenever you have an x squared inside your equation, to solve it, you must have it set equal to 0 first. So what's nice about these problems, they're already set equal to 0. So once we do this factoring, it has to equal 0. So here's where this lesson is different from yesterday. We have to ask ourselves, what numbers would go in here and here so that we make 0? Well, we could do little side equations with each one and say, okay, well, what number goes here for x to make 0? Okay, we'll have to decide, okay, well, x plus 7 is the expression, and I want it to equal 0, so I would subtract 7 from both sides, and that would get me x equals negative 7, right? Or we could just ask ourselves, okay, what number plus 7 makes 0? Oh, I know that the additive inverse is going to make 0 with 7. And then I ask myself the same thing right here. What number plus 6 makes 0? Excuse me. See, I told you I'm not feeling well. So the additive inverse of positive 6 is going to add with it to make 0. So that's going to be negative 6. Well, guess what? These are the two solutions. So we say that x equals negative 7 and 6. And that's our answer. Now, if we wanted to check to see if we're right, we could take these numbers and plug them into the original equation. So just to prove it this one time, if I plug in negative 7 into this equation, it would be negative 7 squared plus 13 times negative 7 plus 42 equals 0. So if I do all this work and it equals 0, then I know negative 7 is a correct answer. Well, negative 7 squared is positive 49. 13 times negative 7 is negative 70 and 21, so that's negative 91. Plus 42 equals 0. If I put these two together, that will make negative 42. And negative 42 plus 2 does, in fact, equal 0, so it works. If I plug in negative 6 to the same exact trinomial, it would be negative 6 squared plus 13 times negative 6 plus 42 equals 0. So again, negative 6 squared is equal to 36. 13 times negative 6 is negative 60 plus 18, which is negative 78, plus 42 equals 0. When I add these two together, it makes negative 42 plus 42 equals 0, so it works also. So there's proof that negative 7 and negative 6 are the numbers that make this trinomial equal to 0. So the next slide is a try this. I'm not going to pause, but you are, and you're going to try it out. And then you'll hit play and see if your work works out to the same as mine. So you should be paused right now. So again, I'm going to factor this just like we did before. So 24 up here, 14 down here, and I go through all my ways of making 24. I figure out that it is going to be 12 times 2. 12 times 2 is 24, 12 plus 2, 14. So that makes it x plus 12 times x plus 2. I add my equals 0 because this is an equation now. That's how I know I'm solving it. And the additive inverse of 12 is negative 12. And the additive inverse of 2 is negative 2. So the solutions are x is equal to 12 and negative 2. Did you get it right? I bet you did. All right. Moving on to the next example. Okay. So all the rest of the examples are going to be the same type of idea. It's just I'm going to be changing around the symbols in between. So you see we have a negative and a positive. But we learned how to do this before. Because we're still multiplying to make a positive 72. And now we're adding to make a negative 27, which means that both my numbers need to be negative. Because a negative times a negative makes a positive, and a negative plus a negative make a negative. So 72. Most people know 9 times 8. And that's their favorite way of doing it. But even if we make this negative and negative, negative 9, negative 8 is not negative 27. So that does not work. So this is going to be a way that we're not used to doing. Some people might know 6 times negative 12. Negative 6 times negative 12. That makes positive 72, but when we add, it makes negative 18, so that's not going to work. So if 9 goes into it and 6 goes into it, what other number do you think goes into it? Well, hopefully you thought 3, because 3 goes into 6 and 9. Because if we use negative 3 times, and let's see, negative 3 goes into this twice, and that would leave 6, so leave me at 12, and 3 goes into 12 4 times, so negative 24. And if I look, negative times negative makes positive 72, negative 3 plus negative 4 makes negative 27. So not one of the more common ways of making 72, but if we know our division rules, we can figure that out because we know that if something can be divided by 9 and 6, we can definitely divide it by 3. So this turns into x minus 3 times x minus 24 equals 0. So again, this is a negative 3 in here. So what's the additive inverse? That's right, a positive 3. This is a negative 24 in here. So what's the additive inverse? 24. So those are my solutions. X equals 3 and 24. Because just remember, we're trying to make 0 inside the parentheses. So 3 minus 3 makes 0. 24 minus 24 makes 0. So that's what we're trying to do. So again, pause it. You got to try this coming up. You should be paused. I'm not. Okay, our x is right here, 66, negative 17. Most common way I can think of to make 66 is 6 and 11. Make them both negative, because negative times negative is a positive. Negative plus negative, 6 and 11, 17. So this is going to be x minus 6, x minus 11. Ask myself what additive inverse would go in here with negative 6, and that would be positive 6. What additive inverse goes in with negative 11? Positive 11. So x is equal to 6 and 11. So your answers are positive whenever the numbers in here are negative, and your answers are negative when the numbers in there are positive. So it's always the additive inverses that are going to be the solutions. Okay, example 3. Again, all you see is I changed up the signs. I now have a plus and then a minus. It's still the same process, though. We're going to have negative 45 up here. This means I have to do a negative times a positive. And what sign should the bigger one be? The sign of this number down here. So positive 4 means my bigger number is going to be positive. Smaller number will be negative. So I'm just going to go for the most common way of making 45, and that's going to be 9 times 5. Most people know that. I mean, there's 3 times 45 and so on, but 9 times 5 is normally the most common. And if we make the bigger number positive, which means the smaller number is negative, positive 9 times negative 5 does make negative 45, and 9 plus negative 5 makes positive 4. So this works. So this is going to be x plus 9 times x minus 5. And now I'm going to ask myself about the additive inverses to make 0 in here. So the additive inverse of positive 9 is negative 9. And the additive inverse of negative 5 is positive 5, because negative 9 plus 9 makes 0. 5 minus 5 makes 0. And that would be my solution. So you see, when the signs are different up here, well, not really when the signs are different. When this second sign is a negative, you're going to have one of each in your solutions, a positive and a negative. Just like you do over here, a positive and a negative. But as you see, they're the additive inverses. All right. So again, pause. You got to try this. This one's a little bit of a doozy, so you should be paused. So negative 120 up here. And we got positive 7 down here, which means my bigger number will be positive. 12 times 10. Even if I make the bigger one positive, that's going to make me, whenever I add it, it's going to make 2. No good. If I try 5, negative 5, because 5, and that would be twice 24, and 24 minus 5 does not make 7. No. So this one's a bit of a doozy. Okay, but hopefully you kept working and you found out that it's going to be 15 times 8. Okay, and if I make this negative, because the bigger number should be positive because of that, 15 plus negative 8 will make my positive 7. So this is 15 and negative 8. So you can almost figure out that the solutions are going to be the additive inverses of these. It's going to be negative 15 and positive 8. But I want you to get used to writing out all the work, because when you get into Algebra 1 next year, you're going to find that some of the problems aren't quite as easy as just saying, oh, additive inverse of this. So don't get used to just doing that, but it does kind of work on these problems. So again, additive inverse of positive 15 will be negative 15, and additive inverse of negative 8 will be positive 8. So x is equal to negative 15 and 8. This isn't that bad, is it? All right, last example. So, of course, negative and negative. But it's the same process. So, negative 56 right here. What am I trying to make down here? Oh, don't forget, negative x means negative 1x. So I'm trying to make negative 1. And also don't forget, it means that my bigger number is going to be the negative. Most common way to make 56 that people know is 8 and 7. The bigger number is negative, and if I add negative 8 plus 7, I get negative 1. So it works. So x minus 8, x plus 7. Additive inverse of negative 8 is 8. Additive inverse of 7 is negative 7. So x is equal to 8 and negative 7. Okay, pause it. Do the try this, and this is the last one. Okay, so you should be paused. I'm going to do my work. Negative 75, negative 10, bigger number negative. I know that this is going to be negative 15 and positive 5, because negative 15 times 5 is negative 75. Negative 15 plus 5 is negative 10. All right, that means I've got x minus 15. I've got x plus 5. Additive inverses are going to be 15 and negative 5. Now, the only reason why that little trick about just looking at your x's and you can figure out that it's the additive inverse of these works is because there's nothing in front of the x squared. As soon as you put stuff in front of the x squared, that little trick doesn't work. So that's why I want you to get used to doing this, because next year, you're going to have numbers in front of here. All right, so that's the lesson. Hopefully you understand it. Hopefully you're doing well in the worksheet coming up. See you guys tomorrow.